Okay guys, because the weather's not cooperating, going to do a little training video on chilled water air handlers this week until I can get back up on the roof and finish my series on economizers on rooftop units. So just going to try to cover the basics in this video today. So if you're well versed in chilled water, I apologize for going over some basic stuff, but just want to make sure everyone's on the same page and has the same foundation going forward with this. So in a mall where there's chilled water and we have air handlers that we work on, the mall has the chiller in their mechanical room, their chiller room, their boiler room, their penthouse, whatever they call it. They are in control of the chiller. And depending on the mall, this is where these animals get complicated, guys. Don't let it scare you, but every mall is engineered differently. Some of the malls were built in the 60s, some in the 70s, 80s, 90s. Different mentalities, different technologies. Some of the malls in the 60s have been modified. So you got to pay attention, is what I'm trying to say. You have to get to know the mall engineer. You have to get to know how your mall functions, because they all operate based on what they want to do. It's their mall, their chiller, their equipment. So we are not in control of that, but you have to understand what they are trying to accomplish. Otherwise you'll never know what your unit and your store should be or shouldn't be doing. You really have to understand the whole system, is what I'm trying to say. So mall has a chiller. Malls, especially nowadays with the economy and energy savings, guys, they don't want to run this chiller unless they have to. So a lot of them do it based on outdoor air temperature. Once the outdoor air temperature is above 55, 60, 65, 70, every mall is different. The mall decides that when they will turn the chiller on. So let's assume it's summertime, they're running the chiller. Some malls have pumps. Most malls have pumps in their mechanical room to recirculate the water from the chiller through the pumps up to the stores, through the whole piping system, and water just flows in a big circle, everyone. The water just goes out cold, picks up heat from air handlers, comes back to the chiller warm, gets cooled back off again, and just, that's all it does, is goes around and around all day long. Some malls, I've seen this in the Chicago and Wisconsin area a lot, they have minimal pumps in their mechanical rooms, and they actually have pumps. Every store has its own pump on the air handler. So by doing that, the store picks up the electric bill for moving the water through the system for the mall. It saves the mall a ton of money. It also moves the maintenance of said pump to the customer, which means it moves that maintenance of that pump to us as technicians for MetroTech. So keep that in mind. Just every mall is a little bit different. Every mall has different logic and different ways of running their plant. So you need to know what they're trying to accomplish before you start taking steps to fix or repair or change things. You have to work within what they are doing, within their operation logic. So, basics. Chiller, pumps, sometimes in the mall's plant, sometimes in the mall's plant and the store, sometimes just in the store and not in the mall's plant. Again, you got to ask questions. Basic logic or basic terminology I want to talk about a little bit, guys, is water or glycol. You need to pay attention to that. Again, this is the mall's decision, not yours, not mine, not ours. The other thing you need to pay attention to is do they have a boiler and a chiller, or do they have just a chiller? If they have a boiler and a chiller, they might have a 4-pipe system where they have a chilled water supply pipe, a hot water supply pipe, a chilled water return pipe, and a hot water return pipe to the boiler. That is what we would typically call a 4-pipe system. Or they might just have a two-pipe system. Let's say they just have a chiller. Again, every mall's different. One pipe going out and water supply into a coil on an air handler, and one pipe coming out, water return. That's a two-pipe system. Now this is where it gets a little bit complex. Again, depends on the mall. Some malls have two pipes, one supply, one return, but down in the plant, they tie these two together with valving, and in the winter, they heat the water in this loop. In the summer, they chill the water in this loop. So it's a two-pipe, but it's hot water in the winter and chilled water in the summer. That two-pipe system with a boiler is, you really got to pay attention, because the air handler needs to know if it's calling for air conditioning, but the mall is running the boiler. You don't want to open an actuator and run hot water through the coil. There's a lot of extra controls added to make sure that so that the unit knows if it's running chilled water or hot water, and what to select, when to open the valve, when not to. So it gets a little bit complicated there, but pay attention to what the mall has before you start messing with controls. If you don't know what is in the pipe, or if it's chilled water, hot water, or a combination, then don't start changing controls and wiring until you understand the system, is what I'm trying to get at. So again, mall controls this and this. Mall also decides if there's water in the pipe, or water mixed with antifreeze, aka glycol, what percentage, what it's rated to for freezing. Based on this, guys, is also where the mall decides whether we're draining coils in the wintertime or not. Some malls have glycol. They run their recirc pumps in the wintertime on their chilled water when it gets below freezing, so that the water is circulating and they don't freeze up. That is their decision. You have to understand what they want and what they're doing before you piss them off. Work with them, don't work against them. Understand the logic is what I'm trying to get to. Talk to the mall guy, talk to the mall guy, talk to the mall guy. And just get to learn them all. So, I wanted to show again, just basics. Piping. This is representative of an air handler of a 4-pipe system. Chilled water coil and a hot water coil in the same unit. Chilled water piping and hot water piping. Hopefully some of you have noticed, this is something I see a lot in the field. I've seen over the years mistakes are made because people don't know, installers, but it's up to us to find the stuff and see it when we start working on the unit. You'll notice that I've got the supply pipe on the bottom of both of these coils. Most of you have already figured out why, or already know why, but if you ran water into this coil on the top and come out the bottom, you would never fill this coil 100% with water. It would trickle down. You'd have air pockets within the tubes in there. You'd never guarantee that that coil was 100% saturated inside the tubes with liquid and not liquid mixed with air. If you run the water in the bottom, it fills the coil and pushes the air out. You will always be 100% full of water in the coil. If you're 100% full of water, you've got better heat transfer. Just basic thermodynamics, everyone. The other thing you'll notice here is that typically, depends on the mall again, some guys do it differently. Typically, your valve, your control valve for your hot water or chilled water is on the return pipe coming out of the unit, not on the supply pipe. For the same reason I just talked about, you want this coil full of water all the time. When the call for cooling ends, this valve shuts, this coil is 100% full of water. There's no air in it. When the call for cooling comes on, it just simply allows the water to start flowing again through the coil. So pay attention to that. The other thing I want to show you here is that in a 4-pipe system, and I've seen this done incorrectly multiple times, is if you take a close look at one, if you have a 4-pipe, the hot water coil is, if we assume airflow coming from the bottom here, Airflow comes in, will always come to the hot water coil first. So through the air filters to the hot water coil, through the hot water coil, and then to the chilled water coil, then to the blower and the discharge duct going out of the unit. Reason for that is two things. Main thing is the hot water coil protects the chilled water coil. It's part of the freeze protection logic. There's heat in front of the cold water coil from the economizer, or the cold air coming in from outside if something goes wrong. The other thing you'll notice if you look at them close, guys, is notice how I've got lines on the hot water coil and there's much more lines on the chilled water coil. If you look closely at a 4-pipe system, hot water coil in front of a chilled water coil, the space between the fins on the coils on the hot water coil are wider on the hot water coil to allow the airflow to get through and get to the chilled water coil, so it doesn't restrict the airflow. So if you put chilled water in this coil, if someone pipes it backwards and you've got chilled water going into this coil, number one, you don't have as much contact time, so you won't cool as well. So if you have a cooling problem in a store that you've never been able to figure out, you could be piped backwards. You could have the chilled water going through the hot water coil. It's not designed for that. The other thing you have to pay attention to is because there's a bigger gap here, the air goes past this coil. This coil doesn't get dirty. So you might look in here and say, hey, these coils are clean, I don't need to wash them. All the dirt's going to be sitting packed onto this coil. So you have to open up sheet metal. You might have to cut a hole, remove panels. You've got to look at and clean the space. You know, if you had these two coils sitting like this, you can get in there and see that. A lot of times I see that second coil, just like a condenser coil when you got to split and wash them. This coil will have all the crap on it. And that will kill your airflow, kill your cooling, obviously. So enough on that. Quickly while I'm here, most malls nowadays have a 3-way valve for the valve instead of a 2-way valve. They do that so that there's always water going back to the plant, the cooling plant or the chilled water plant. You need to pay attention to that because that changes the logic of the unit. The other thing I wanted to note while I'm here is you'll notice that on the hot water coil, notice how I have, that doesn't say no, that says NO for normally open. If it's set up properly, guys, if you have a 4-pipe system, the hot water coil, the actuator and the valve for it these should both be spring return actuators. So in a power failure or a alarm state, when you kill power to the unit, this hot water valve opens and allows hot water to flow through the coil. That quickly warms the coil, quickly warms the inside of the unit, and it's a part of the freeze protection. You don't want to have both of these coils the same, or both of these valves the same logic. You want this hot water valve to be a normally open valve. You want this valve to be a normally closed valve. Spring return. You kill the power to the unit. This valve shuts off the chilled water. This valve opens, allows hot water, if there is any, to go through the coil so it doesn't freeze. What else do I have here? 2-pipe system, like I was just talking about. Here's a coil.